we make the jet airplane? Not exactly. Do we make the big rig semi? Not exactly. Do we serve the soft drink at the local burger barn? Not exactly. But many plastic parts for these and millions of other products around the world are thermoformed. Everything from the drink lid at your favorite fast food restaurant to precision aerospace components, more and more products every day are being improved by the use of thermoformed plastics. This short video will introduce you to thermoforming, what it is, what it's used for, and why designers and engineers have relied on this process for years. Thermoforming isn't new. It's been around since the early days of plastics. It's one of several processes that turn plastic raw materials into useful components. Today, it's one of the fastest growing segments of the plastics industry. Thermoforming starts with a sheet of extruded plastic. First, raw plastic pellets are heated until they're melted. The molten plastic is then squeezed into a sheet, cooled, and is then ready to be thermoformed. This sheet is heated until it's soft and flexible. The material never becomes liquid or gooey. Instead, it's more like a piece of vinyl or soft rubber. The hot sheet is forced and stretched to take the shape of whatever parts are being produced, usually against a mold of some sort. After the sheet cools and again becomes stiff, it holds the new shape. The parts are then trimmed to their final size with all necessary cutouts, holes, etc. There are two main divisions within the thermoforming industry, based on the starting thickness and configuration of the sheet material. Thin gauge or roll-fed thermoforming uses sheet material thin enough to be delivered on rolls, about 1/16 of an inch and less. Many plastic packaging products are created using high-speed, high-volume, roll-fed continuous forming equipment. Soft drink cup lids, retail packaging, and clamshell containers are all examples of thin gauge or roll-fed thermoforming. Heavy gauge or cut sheet thermoforming uses thicker raw material, up to about 1/2 inch thick and greater, delivered in sheets and formed using equipment specifically designed to handle the thicker sheet material. Examples of heavy gauge thermoforming include shells, housings, covers, and trays. Within the broad heading of thermoforming, there are many techniques used to get the job done. You may have heard of vacuum forming, a basic process where the air between the sheet and the mold is evacuated, allowing atmospheric pressure to force the hot sheet to stretch and conform to the mold surface. Pressure forming adds additional air pressure on the non-mold side of the sheet, achieving highly detailed finished parts, approaching an injection molded look at reduced tooling cost. Twin sheet forming is an exciting new innovation in thermoforming. By molding two hot sheets at the same time against two molds and then fusing the sheets together, a whole new world of design possibilities opens. Twin sheet offers a new way to manufacture hollow parts with better structural integrity. When designers and engineers specify thermoforming for the production of their plastic components, they know the cost of the molds for those components will be considerably less than for other processes. But there's more to the story. Not only are the molds less expensive, but they can also be produced in far less time. This means you get your product to market faster. Also, thermoform parts retain far less internal stress than similar injection molded parts. Thermoforming is one of the fastest growing plastic processing industries today. There are over 250 companies in North America alone that do cut sheet or roll-fed thermoforming. More than a third of these companies had sales over $7.5 million a year. These firms are in every state of the Union, plus Canada and Mexico, and process over 1 billion pounds of plastic resin annually. So take a look around. You'll be amazed at all the thermoform products you see every day. The creamer you open to fix your coffee, the aircraft overhead luggage compartments, the clear retail pack that allows you to see the product before you buy, the sealed sterile medical container for life-saving surgical implants, a bass boat hull or canoe. From the 18-wheeler cab to the dashboard, door panels, and many exterior panels on more and more new cars, thermoform parts are just about everywhere you look. To learn more about thermoforming, contact the Society of Plastics Engineers Thermoforming Division at thermoformingdivision.com.